Hello everyone, very good morning and welcome to BYJU'S Exam Prep, most comprehensive app for all exams. First of all, inform me that sound quality, picture quality, everything is fine. Please inform me that sound quality, picture quality, everything is fine. Yes. Now, this is one important session for you. Okay. This is a BARC and HAL 2022 analog part 1, right? And here we are going to discuss some important numericals on diode circuits and BJT, right? BJT and MOSFET, right? So please join the session, share the link of this session in your group. Okay. Now guys, what about the analog? Now analog is going to play a crucial role in your selection and number of questions from this topic, that is analog, right? Now, which topics are important? So diode circuits, right? Then what? BJT and its application, special diodes like what? Zener Diode, and what second thing is MOSFET, right? And operational amplifier. So in part 1 we are going to discuss diodes and what? BJT, and in part 2 we will discuss MOSFET and application of operational amplifier, right? Each and everything. So please revise the session with important and conceptual numerical. But please, first of all, share the link of this session. Okay. Now, this is my introduction. Myself, Sanjay Rathi, 20 plus years of teaching experience in the field of competitive exams like ESE, GATE and PSU. कहाँ से टॉपिक्स आएंगे मैंने आप लोगों को अभी बताया, तो जो भी इंपॉर्टेंट टॉपिक्स मैंने आपको बताए हैं पूरा रिवाइज कर लीजिए और उन पर कुछ इंपॉर्टेंट न्यूमेरिकल्स भी सॉल्व कर लीजिए. नाउ दीज आर माय रैंक्स. AIR 16 in ESE 2005 and AIR 21 in ESE 2008, and I worked as deputy director in Ministry of Power, and I have mentored more than 1 lakh students for these exams. So these are my area. Now that is one important session for you, that is how to start preparation for GATE 2023 and 2024. Now you are focusing on GATE 2023 or 2024, then this is the session for you. Okay, complete strategy and what is the right time to start the preparation and what are the tips and tricks by Rakesh Talreja sir and Asutosh Saxena sir. Okay, and this session is very important on 5th March 8 PM. चलिए अब आते हैं, दैट इज वन इंपॉर्टेंट न्यूमेरिकल फ्रॉम द डायोड सर्किट, दैट इज द एप्लीकेशन ऑफ द डायोड. प्लीज गिव मी द आंसर फॉर दिस पर्टिकुलर क्वेश्चन. यस एवरीवन. नाउ BARC and HAL 2022 analog part 1, and that is the question on what? Clamper, right? This is the question on clamper, and this is what are the applications of the diode circuits? Clipper, clamper, rectifier, filter, voltage regulators, that is by using the Zener Diode, and voltage doubler. So you will get the direct question from these topics: clipper, clamper, voltage doubler, rectifier, and what? Voltage regulators. Okay, please give me the answer for this question. Select the correct output V0 wave shape for a given input Vi in the clamping network given below. Okay, तो आप एक बार जरा जो भी अटेंड कर रहे हैं अपने कमेंट्स दीजिएगा, क्या साउंड क्वालिटी, पिक्चर क्वालिटी, एवरीथिंग इज फाइन, राइट? प्लीज इन्फॉर्म मी. देन watch this question. If we are having the diode here, that is the 2 volt battery, that is the resistor, this is the C, and that is the input, my dear friends, and that is the 4 options A, B, C, D. So normally straightforward question from clamper, straightforward question from the clamper is what is this clamper? Positive clamper or negative clamper? Give me the comments. Positive or negative clamper, everyone. तो जब हम देखेंगे डायोड का जब एरो है, अगर इफ इट इज डाउनवर्ड, देन इट इज अ नेगेटिव क्लैम्पर. It is what? Negative clamper, right? And when it is negative clamper, always remember the capacitor will charge like this. Capacitor will charge like this. Okay, 1 minute. तो बताइए what is the answer for this particular question? ये कौन सा आंसर होना चाहिए भाई? right? Now this is a clamper circuit, it is a negative clamper, and the capacitor will charge like this. Always remember this. This is the direction of current, diode is forward bias, this is the 2 volt. To the maximum positive value, what is the maximum positive voltage? 10 volt. Now the capacitor will charge. They may ask what is the voltage across the capacitor. Always remember that is the 10 minus this 2, that is the 8 volt. 8 volt is the voltage across the capacitor. Once the capacitor will charge, once the, yes, single, in next class we will discuss operational amplifier. Tomorrow at 11 AM we are going to discuss operational amplifier and MOSFET. Priya Mohan, very good morning. Shiva Ram Ravichandran, very good morning. तो देखो ये क्लैम्पर है, and they may ask what is the voltage across the capacitor, that is the 8 volt, and what will be the output? Output is always Vi minus Vc. Vi minus Vc, when we are subtracting the 8 volt from this, so this 10 will become what? 2, and this minus 10 will become what? Minus 18, and that's why the output is 2 minus 18, 2 minus 18, and that is the answer. That is the answer for this particular question. So always remember, the output have the same swing as what? Input. Shape of the output will be similar to what? Shape of the input. Frequency of the output will similar to frequency of the input, only the change in what? DC level, and that's why it is called DC inserter, DC restorer, right, or DC translator. These are the name of the clamper. So this is a very, very simple diagram. That is what clamper circuit. Now second one, second question, please give me the answer. अगर ये यहाँ पे आ जाता है, ये this is the, simply I am changing the diagram. Simply I am changing the diagram. What is the name of this clamper, everyone? If I am using this capacitor, positive or negative clamper, and output is clamped at, let this is the 5 volt. This is the V0. This is the Vi. Tell me what is the name of this clamper, everyone? What is the name? If we are having the input like this, okay, and this is the 15 volt and this is the 0 volt, like this is the minus 15 volt. So what is the maximum and minimum value of the output? What is the maximum value of the output and what is the minimum value of the output? What is the peak value of the input? Negative peak and positive peak of the output. If the negative and positive peak of the input is 15 and minus 15, yes, we should cut the wave, na sir? No, that is in case of clipper, not in the clamper. That is in the case of what? Clipper. In a clamper, we are simply adding what? DC level. We are adding negative DC level or positive DC level. That's why clamper are two types: negative clamper or positive clamper. Only change in what? DC level. Right? Shape will remain same. So for example, this is a diode, right? Watch this diode. Very easy to remember this. If this is the arrow upward, so it is a positive clamper. It is a positive clamper, and the lowest level is what? 5 volt. This is the base. This is the lowest level is 5 volt. So what is the lowest value? 5 volt. Always remember, this is the lowest level, 5 volt. Now the swing will remain same. 15 plus 15, that is the 30. The highest value will become 35. Lowest level will become 35. And this is a very, very easy to solve this type of questions. This is what? 35, and that is what? 5. So this is the minimum value of the output, that is the maximum value. The shape will remain same. There is no change in the shape. Maximum you are giving the 20, minimum you are giving the 10. My dear friend, remember what is the, देखो कभी भी जो लोवेस्ट लेवल है ना, ये यहाँ से डिसाइड होगा, दैट इज द 5 वोल्ट, एंड द स्विंग इज लाइक दिस 5 and 35. The swing will remain same. Swing will remain same. And right, that is the question. That is the question. What is the DC level? The DC level of this, you can calculate the DC level. always remember when we are calculating the DC level, V maximum plus V minimum divided by 2. Maximum is 35 plus 5 divided by 2 means it is a 20 volt. The DC level of this signal is 20 volt. यहाँ से देखिए, this gap is what, 15 volt, this gap is also 15 volt. So 20 volt is the DC level. Okay, now if the 20 volt is the DC level, simply what is the voltage across the capacitor? What is the voltage across the capacitor? This voltage across the capacitor is what, when we are calculating the VC, then always remember, if it is a positive clamper, this will be the negative value, minus 20 volt. This is the DC level and that is the minus 20 volt. You have to add the 20 to what, 15 and 20 to what, minus 15 volt. Okay. Okay, Nani, how are you? Chaliye, Rohit Yadav, sir, what is the expected cutoff for the instrumentation engineering this time? यार ऑलमोस्ट देखो, इंस्ट्रूमेंटेशन थोड़ा सा मैं और डिटेल इसका पता करके मैं आपको बता दूंगा. और कोई क्वेश्चन है आपके पास? चलिए, रोहित यादव, ज्वाइन माय टेलीग्राम चैनल, आई विल अपलोड द कट ऑफ फॉर ऑल द ब्रांचेस. सिंपली इलेक्ट्रॉनिक्स बाय संजय राठी. देन अब आप नेक्स्ट क्वेश्चन आता है, जरा नेक्स्ट क्वेश्चन देखिए. अब बताइए क्या होगा. व्हाट इज द आंसर फॉर दिस क्वेश्चन? दिस इज द क्वेश्चन ऑन क्लिपर. दिस इज द क्वेश्चन ऑन क्लिपर. कंसीडर द फॉलोइंग सर्किट. फॉर द सर्किट शोन बिलो, which one of the following is the correct statement? D2 does not conduct for any value of the VI. ये देखो, ये D2 है, ये D1 है. 10 किलो ओम 10 किलो ओम रजिस्टर है, 10 वोल्ट की बैटरी लगी हुई. दिस इज द 10 वोल्ट बैटरी, 10 किलो ओम D2, दिस इज द D1. Here we are connecting the VI. Now which statement is correct? Which statement is correct? That is the question on what? Clipper. That is the question on clipper. अच्छा, EMFT कंप्लीट नहीं हुआ. फॉर विच एग्जाम? बार्क. यस, सुरजीत रविदास, 20 वोल्ट इज द डीसी वैल्यू. बिल्कुल सही. एक बार जरा आप अपने ग्रुप में शेयर कर दीजिए सभी. अरे आज थोड़ा डिले हो गया बिकॉज ऑफ टेक्निकल इशू, तो सभी बच्चों को बोलिए आ जाएं, बिकॉज दिस एनालॉग इज वेरी वेरी इंपॉर्टेंट सब्जेक्ट फॉर व्हाट बार्क एग्जाम एंड HAL एंड अदर कमिंग एग्जाम्स, राइट. तो थोड़ा सा देख लीजिएगा क्या होता है. Now this is a clipper. First question from clamper, second question from clipper. Clipper is also called what? Slicer. Slicers. Amplitude selector, because we can select the amplitude. Amplitude selectors, amplitude limiters, right? So this is a clipper. Now always remember, if we are assuming the ideal diodes, let the diode is ideal. First of all, make a proper table for this. That is the table. We are having the two diodes. This is the VI. We are having the two diodes D1 and D2, and what will be the output? This is the proper table for clipper, right? Answer given by that is C. Just I will check. Very good morning everyone. Right. आप बताइए, VI, because it is a less than 0, then you can put the value, let it is less than 0, negative value. You can choose any negative value. Watch this diode. If we are putting the negative value, right, here it is a 10 volt. The 10 volt will make this diode reverse bias, and this negative value will make this diode D1 reverse bias. Both are off. Initially both are off. Right, when both are off, always make a proper diagram. Let this diode is off. This will act as open circuit. This diode will also act as open circuit. And then this is the 10 volt. What is the output? Output 0 volt, because there is no drop across this 10 kilo ohm, no drop across this 10 kilo ohm, and VI is isolated. Now we are getting the 0 volt. For VI less than 0, it is 0 volt. Now it is a MCQ. It is a MCQ. Only one statement is correct. Which statement is correct? V0 is 0 volt for all values of VI less than 0. No need to check. No need to check the other answer. Explain fully in English. Some of the students. Okay, Pooja. Okay. Okay then. Now. So this is a clamper, this is a clipper. where we are having the two diodes, ideal diodes D1 and D2, and 10 kilo ohm and 10 kilo ohm. Now watch this. First case, Vi less than 0, both the diodes are off, and what is the output? 0 volt. One answer is correct, that is the C option. Now, further, when we are increasing the value Vi greater than 0 volt, less than equal to 0 is less than or equal to. Suppose, if it is greater than 0 volt, then what will happen? This diode, when we are making it positive, this diode D1 is on. What about the D2? Because of the 10 volt, this D2 is off. This is on, this is off. Right. You have to make the second diagram, short circuit, 10 kilo ohm, 10 kilo ohm. This diode is off. Everyone please tell me what will be the output. Now this will become Vi by 2, because this is the Vi, this is 10, this is 10. According to voltage divide rule, this will become Vi by 2. Vi by 2. Okay. Now next thing, next one. If this voltage is what Vi by 2. Watch this diagram, the diode. On negative side 10 volt is connected. Diode D2. On negative side 10 volt is connected. On positive side this is the V0, or V0 is nothing but Vi by 2. And when this Vi by 2 is greater than or equal to 10 volt, means when Vi is greater than or equal to 20 volt, D2 will conduct. D2 will conduct. Means this range is valid for what? 20 volt. Now when the Vi is greater than or equal to 20 volt, this is already on. Now this diode is on. What will be the output? You have to make the third diagram. This is on, make it short circuit. This is on, make it short circuit. Once it is short circuited, what is the output? Output is fixed at what? 10 volt. Output is fixed at 10 volt. Very simple question. Very simple question. So how to deal with what? Clipper. Simply proper range. What is the range of the input? So that is the table. Now it is fixed at what? 10 volt. First of all, less than 0. From 0 to 20 volt. First breakpoint is 0 volt. Second breakpoint is what? 20 volt. And third is what? When greater than 20 volt. Both the diodes on. And what will be the question? What is the minimum value of the output? 0 volt. What is the maximum value of the output? 10 volt. Okay. Nani, how to get the Vi by 2? Yes, watch this diagram, my dear. Watch this diagram. This is the 10 kilo ohm resistor. This is the 10 kilo ohm resistor. This is the Vi. Simply use the voltage division rule, because this is the V0 and we have to calculate the V0 here. Tell me what is the V0? 10 divided by 10 plus 10 into what? Vi. What is the output? Vi by 2. Simply because we are having the two resistor, 10 kilo ohm, 10 kilo ohm, simple voltage division rule. Now it is clear to you? Now it is clear to you, everyone? Yes. So that is the question on what? Clipper. Now they may ask what transfer curve. If they may ask transfer curve, write down the line. This is the line. Right, always write a dash line. Watch the diagram in objective, because it is MCQ. So this is the slope of this line is what? 1. Always remember the slope of this line is 1. Transfer curve means Vi versus V0 versus Vi. Now when this is the 0, this is the first breakpoint, and second breakpoint is what? 20 volt. Watch this. This is the 20 volt. Because the slope of this line is, this is the 20 volt, this is the output, that is the input. Now watch this diagram. Up to 0 volt, output is 0. Output is 0. Then after that, it will follow the slope of this line is 1, but it will follow the Vi by 2, that is the value. And after that, this is the case. Yes, this is the value. So what is the slope of this line? Vi by 2. When the output is 20 volt, what is the, when the input is 20 volt, what is the output? output is 10 volt. So this is called transfer curve. This is 0 is called breakpoint, 20 is called breakpoint, and this white line is called transfer curve. V0 versus Vi. ये है क्वेश्चन ऑन क्लैम्पर, सॉरी ऑन क्लिपर. तो ये है क्लिपर. तो देयर इज अ राइट चेंज इन द वेव फॉर्म, राइट. ओके, स्लाइसर, वी कैन लिमिट द एम्पलीट्यूड. नेक्स्ट क्वेश्चन. नाउ इट इज क्लियर. ओके देन चलिए आते जरा तीसरा देखिए. ये ट्रांसफर कर्व, दे मे आस्क व्हाट इज द मैक्सिमम वैल्यू एंड मिनिमम वैल्यू फर्स्ट. विच टाइप ऑफ क्वेश्चंस ऑन क्लिपर? दे मे आस्क व्हाट इज द मिनिमम एंड मैक्सिमम वैल्यू. They may ask this type of questions. देखो, D2 does not conduct for any value of Vi. Wrong. Because D2 will conduct for Vi greater than 0 volt, greater than 20 volt. This is the wrong statement. V0 is 10 volt for all values of Vi greater than 10 volt. Wrong. V0 is 10 volt for all the values of Vi greater than 20 volt. This statement is wrong. 0 volt for all the values, that is the right statement. V0 is 10 volt for all values of Vi greater than 0 volt. Wrong. Vi greater than 20 volt. This is also wrong, and that is the right answer. That may, or they may ask what transfer curve. This type of questions from clipper circuit. Clamper, positive clamper, negative clamper, right, and simply output. Now third diagram is what? Doubler. Voltage doubler. This is a voltage doubler. Capacitor, diode, capacitor. Please give me the output V0. What will be the output? Everyone use your calculator, because in BARC exam calculator is allowed, but in HAL I think not allowed. So you can use, right? Please give me the answer. What is the answer for this question? In the circuit shown below, all components are ideal. Input voltage is sinusoidal. 230 volt RMS दिया हुआ. This is the RMS value is given. Input voltage is sinusoidal. The magnitude of the steady state output V0 under steady state condition, the capacitor will act as what? Open circuit. तो everyone give me the answer. क्या दिया है भाई? यहाँ पर दिया हुआ है सुरजीत रविदास D. Okay, what is the D? 650.5. right. Now my dear friends, remember that this is a doubler. Now when we are dividing it into two parts, first and then second part, it is nothing but positive clamper. Right. Now this is the RMS value. So what is the peak value? The peak value is equal to √2 times of RMS value for sinusoidal signal. It will become 230 into √2. Now this is called positive peak detector. So first of all, voltage, this clamper, positive clamper will make it double. Let it is a sinusoidal signal. If the input is a sinusoidal signal like this, then first of all clamper will make it like this, just double. What is the value? 2 Vm. This is the output of the clamper. Now what is this peak detector? So peak detector will detect the positive peak. After peak detector, the curve is like this, constant value. So this is the doubler, and you are going to get the 2 Vm maximum value. So what is the 2 Vm? Make it 2 Vm. This is the Vm. So what is the 2 Vm? 2 Vm will become 230 into 2, 460 √2. 460 √2. Now multiply it what? 1.414, 460, and you will get the answer D. So this is a doubler. Okay, remember this. You can get one question from doubler, right? Now what will be the output for this diagram? If I am giving the same question, just I am changing the position. That is the diode, right? What will be the output, everyone? Same input. That I am giving the 230 volt RMS. 230 volt RMS. Now you have the answer. 230 volt means what? 650.5. So in this diagram, what will be the output? And in that diagram, what will be the output? We have the two figure. This is the 230 volt RMS we are giving here, then sir, IRMS syllabus for preliminary is same as that of the CSE. They are simply according to notification they will conduct IRMS exam through what? Civil services exam, right? Further we will get some information about that, okay, no doubt. The UPSC will give the information or notification what about the other pattern of IRMS and so on, then definitely we will inform you. Now 230 volt is the RMS value. This is the capacitor, diode, that is the capacitor. What will be the output? What will be the output? Always remember, this is a negative clamper, and that is what? Negative peak detector. Negative peak detector, and that's why the output is what? Minus 2 Vm. And when the output is minus 2 Vm, then it will become minus 650.5. Minus 650.5 volt, right? Okay. Or second thing, बहुत बढ़िया, बहुत बिल्कुल सही है. This is a clamper and in second diagram, because it is a negative peak detector, this one, negative peak detector, sorry, this is a negative clamper, but it is followed by positive peak detector, and that's why the output of this diagram is what? 0. Always remember, if we are having the two diodes or two capacitor, means every diagram is what? Voltage doubler. That is not so. There should be a proper connection. Negative clamper should be followed by negative peak detector, and positive clamper should be followed by positive peak detector. Then 2 Vm, in this case it is a 2 Vm, in this case it is a minus 2 Vm. But if the negative clamper is followed by positive, or positive clamper is followed by negative peak detector, output will be 0. So ये आ गया answer. Now next one. Now again another example is what? Another application of the diode is what? Rectifier. Half wave rectifier, full wave rectifier, bridge rectifier, number of rectifiers with what? Filter circuits, capacitor filter, inductor filter, LC filter, pi filter. What is the answer for this question? Right, so we have half wave rectifier, HWR, full wave rectifier, two types of full wave rectifier, center tapped, transformer type, and bridge rectifier. Right, so full wave rectifier, in a full wave rectifier using the two ideal diodes. What are the two ideal diodes? Only two ideal diodes. So what is the difference between the bridge rectifier and full wave rectifier? In a bridge rectifier we are having the 4 diodes. In center tapped transformer type we are having the 2 diodes. Means here we are talking about what? Center tapped transformer type. Okay. Using the two ideal diodes, VDC and VM are the DC and the peak values of the voltage respectively across a resistive load. VM is the highest value of the output voltage and VDC is the DC value of the output voltage. If the PIV is the peak inverse voltage of the diode, means that is the maximum voltage appearing across the diode when the diode is reverse biased. That is the characteristics of the diode. and diode is selected on the basis of PIV rating. Always remember, when we are going to market to purchase what? Diode, then we are purchasing the diode on the basis of PIV rating, right? Simply we are saying that please give me one diode of this much PIV rating. Diode is selected, and that's why this is a very important parameter now of the diode. Then the appropriate relationship for these rectifiers are, what is the appropriate relationship? VDC is equal to 2Vm by pi for full wave rectifier, and PIV is 2Vm. PIV is the 2Vm, that is for center tapped. For bridge rectifier, VDC is equal to 2Vm by, but PIV is what? Vm. This is for bridge rectifier. Bridge rectifier. This is for center tapped transformer type. And when we are talking about the VDC is Vm by pi and PIV is Vm, this is for half wave rectifier. This is for half wave rectifier. Simple question, very, very simple one. Now, please tell me, that is the use of what Zener diode? 100 ohm, 5 volt, this is the RL, 10 volt. So my dear friends, from rectifiers, please revise the formula for what? Half wave rectifier, full wave rectifier, bridge rectifier. Remember that the bridge rectifier is used for high voltage application. Normally we are using the bridge rectifier for a high voltage application because PIV is less. Second thing, ripple factor of what? Ripple factor for capacitor filter, inductor filter, that is also known as choke filter. Okay, and the difference between the capacitor filter and inductor filter. Then simple formula for what? L section, that is called LC filter, and what? Pi filter, CLC filter. Simple formula based. Yes. So yes, all the formulas are available, then go for that. Okay, or otherwise join my Telegram channel. I will upload already I have uploaded the PDFs of those formula for rectifiers and filter circuit. So you can join my Telegram channel, that is Electronics by Sanjay Rathi. Now tell me, what is the answer for this question? Here we are having the Zener diode. Here this is RL is connected. This is the 100 ohm resistor, and this is the 10 volt. Just I am going to give you the two formula only. Two formula for Zener diode and all the questions from this circuit, that you will be able to solve all the questions on this type of circuit. That is a voltage regulator by using Zener diode. Remember that this is the diagram. Normally we are having this type of diagram. Here we are having the series resistor RS. This is called regulated circuit. This is the Zener diode, and this is what? RL. And this RL is given here. This 100 ohm, this is called series resistor RS, and this is the VI. In this case, this VI is given as 10 volt. No problem. Fixed VI. Right? Always remember one or two formula, that if this is I, this I is divided into two parts. One is what? IZ and one is IL. Zener diode should be in breakdown region. तो आंसर क्या दिया गया है? 125 and 250 milliwatt. 125 and 250 milliwatt. देखो क्या दिया हुआ है सर्किट में. In the circuit shown below, the knee current is given as 10 milliampere. To maintain the 5 volt across RL, the minimum value of RL in ohm and the minimum power rating of the Zener diode in milliwatt respectively are. Right? Minimum power rating. देखिए कैसे निकालते हैं. First of all, always remember there will be a two formula. I is equal to, this I is divided into IZ plus IL. But you have to find the IZ. What is the IZ? I minus IL. This is the very, very important equation, I minus IL. So what is the IZ minimum? IZ minimum is equal to I minimum minus IL maximum. I minimum minus IL maximum. Always remember Zener diode will be in breakdown region. This is the VZ, and output is always VZ, constant. Then simply use this formula I minimum minus IL maximum to get the value of R. How? IZ, watch this. I minimum, what is the I minimum? VI minimum minus VZ upon RS. VI minimum minus VZ upon RS. IL maximum, what is the IL maximum? V naught divided by what? R. RN. RL minimum. What is the minimum value is required? That is the formula. And this current should be greater than or equal to what? IZK. This current should be greater than or equal to IZK. If this current is less than IZK, Zener diode will come out of what? Breakdown region, and circuit will not perform satisfactorily. Okay, and that is the problem. To use this formula, and simply what is the VI minimum? This is the fixed value. Otherwise, you have to use the 10 volt. Always there may be a variation from VI minimum to VI maximum. But here if you are having the fixed value that minimum and maximum all are 10 volt, use this 10 volt minus VZ. 10 volt minus VZ, 5 volt, this VZ is given as 5 volt, upon answer is in what? That is the Zener diode in ohm. Okay, no problem, it is in ohm. This is the 100 ohm minus V0. What is the V0? VZ, 5 volt, upon RL minimum. You have to find the RL minimum. It should be greater than or equal to IZK. What is the IZK? 10 milliampere. Knee current 10 milliampere. But we are using the resistor in ohm. So first of all, convert it into what? Ampere. 10 milliampere means what? 10 into 10 raised to power minus 3 ampere. Now use this formula. 5. This will become 0.05. Right? This is the minus. This is what? 100 divided 1000.01. It should be greater than or equal to 5 by RL minimum. Then we can say RL minimum should be greater than or equal to 5 divided by what? 0.04. 0.04, that is 500 by 4, 125. 125 ohm. That is the right answer. Bilkul sahi hai Surjit. Your answer is correct. 125 ohm. It should be greater than or equal to 125. Then what is the minimum value? 125. So this answer or that answer. Second, we have to calculate power rating. Minimum power rating of the Zener diode. Minimum power rating of the Zener diode. So what is the maximum current through the Zener diode? What will be the maximum current through the Zener diode? We have to calculate the maximum current. When I want to calculate the maximum current through the Zener diode, then we can calculate the power rating. Always remember the power rating is what? VZ into IZ. IZ max. This should be the minimum rating of the Zener diode. So IZ max is equal to I max minus IL minimum. IX minus IL minimum, or IL minimum under under a situation we can remove the RL and this will become 0. What is the I maximum? VI maximum. What is the VI maximum? 10 minus V0. What is the V0? It is fixed 5 upon what? 100, and this is 0.05 ampere. 0.05 ampere. Why you are taking the IL minimum 0? Because once the user will remove the RL, this is the current will become 0, and the complete current will pass through what? Zener diode. Complete current will pass through the Zener diode, and that maximum current is what? 0.05 multiplied with VZ. What is the power rating? 0.05 is the maximum current, and this is the 5. 0.025. 0.25. This is what? In milliwatt it is what? 250 milliwatt. This is the answer. It is in milliwatt to 250 milliwatt. So what is the precaution, my dear friends? Always remember one thing. When the question is related to what? Zener diode, simply when we want to calculate the power rating of the Zener diode, always consider the worst condition. What is the worst condition? When this VI is maximum, there will be the maximum current, and at that same time this IL is minimum. Minimum means if it is possible then remove the RL. The minimum current is 0 and maximum current is what? When the VI is maximum. Maximum minus VZ divided by RS, it will give you the maximum Zener diode current, multiplied it is 5, and you will get the maximum power dissipation. When we are reading the maximum power dissipation, then what should be the rating? Always remember, rating should be always greater than or equal to what? Maximum power dissipation. And that's why what is the minimum rating? Minimum rating means what? PZ maximum. Minimum rating is PZ maximum. Okay, next question. We have only two formula. First one and second one. These are the two very important formula for Zener diode. ओके चलिए अब आप देखते हैं जरा नेक्स्ट क्वेश्चन. अरे भाई जरा एक बार आप लोग अपना लाइक बटन प्रेस कर दीजिए अगर ये सब आपके टॉपिक इंपॉर्टेंट है. डायरेक्ट क्वेश्चंस आएंगे. ये एक और क्वेश्चन, व्हाट विल बी द आंसर ऑन Zener diode? The IV characteristics of the Zener diodes D1 and D2 are shown in the figure. IV characteristics means this is the D2. For D2 the breakdown voltage is minus 70 volt because it will break down in reverse direction. And for D1 the breakdown voltage is what? 80 volt, minus 80 volt. For one it is minus 70, for another is 80. Normally we are saying that because it is in reverse direction, VZ1 is equal to 80 volt, VZ2 is equal to what? 70 volt. Here we are not using the sign. Why we are not using the sign? Because the diode, Zener diode is working in what? Reverse direction. Then that's why no need to mention the sign again and again. So please tell me, if I am changing the value of input from 0 to 100 volt, right? These diodes are used in circuit given in the figure. If the supply voltage is varied from 0 to 100 volt, then breakdown occurs in. किसमें आएगा breakdown? Breakdown occurs means it will allow what? It will allow the current. It will allow the current, right? But my dear friends, these two diodes are connected in what? These two diodes are connected in series, right? And the total voltage required from this point to this point. One D1 is required what? 80 volt. This is required what? 70 volt. Okay. Watch the characteristics also, right? When I am watching the characteristics, continuously the voltage across both will increase, right? When I am increasing the voltage, continuously the voltages across both the diodes will increase and increase and increase, right? So what is the maximum voltage? 100 volt. How we can say that diode D1 will first break down? The complete voltage will come across the D1 and not across what? D2. Or how we can say that the complete voltage will come across the D2 and none will come across the D1? How we can say? Because both have some minimum cut-in voltage, both have some the drop. So my dear friends, if both are connected in series, if one is off, what will be the current through the next one? What will be the current through the next one, everyone? These two diodes are not connected in. These two diodes are not connected in parallel. If these two diodes are connected in parallel, for example, that is the case. If these two diodes are connected in parallel, then let this is the D1, let this is the D2. This D2 will require 70 volt. This D1 will require, right? This D1 will require what? 80 volt. If suppose I am giving 100 volt, then first of all this diode will break down, and now the fixed voltage is 70 volt. Fixed voltage is 70 volt and it will remain open circuit. And the output is fixed at what? 70 volt. Output is fixed at 70 volt. Right? So my dear friends, in this case, when they are connected in parallel, the diode which have lower rating will break down. But when they are connected in series, means no diodes will break down, right? By that, this voltage is distributed because initially they will act as what? Open circuit. Initially both will act as what? Open circuit. That is the case. Okay? I think this is clear to you, everyone. Clear point, because these two diodes are connected in series. For example, sometimes we are having the diodes, and one diode connected in forward direction and one diode is connected in what, this direction. This is the, it will require 0.7 volt, it will require like 10 volt. When the input is, when we are simply saying that when the input is greater than or equal to 10.7, then this diode is forward bias, this diode is breakdown, and then the output will be what, 10.7 volt. 10.7 volt. We are not saying that. We are not simply saying that if the input is greater than 10.7, then this diode is forward bias, but that diode is not. That diode is not breakdown because there is no current. If the current is 0, then please tell me, is that diode is forward bias? Yes, everyone, right? Not, because there is no current. There is no current. There is no current because they are connected in series. The total voltage required is what, 10.7 volt. Similarly, when the two diodes are connected in this one, this will require 80 volt. This is require 70 volt. What is the total voltage required here is what, 150 volt or more than 150 volt. Once it is greater than 150 volt, then both the diodes will break down. And what is the output voltage? That output voltage is constant at what, 150 volt. So Amit, now it is clear to you? Surjit, according to me, that is the answer. Yes, please. Simply concept, because these two are connected in what, series. These two are connected in series. Okay. Then, what is the answer for this question? This is a simple question, so very, very simple question. Right. So, in parallel, lower will break down. Always in parallel, this is yes. This is, if it is a lower, then this will break down. This 70 will break down, 80 will not break down. Once it is break down, the voltage will become constant. In parallel, it is possible. For example, sometimes we are connecting the germanium diode and silicon diode in parallel. Germanium diode and silicon diode in what, parallel? Okay. अब बताइए जरा क्या होगा? In the AC equivalent circuit shown in the right, in the AC equivalent circuit shown, the two BJTs are biased in active region. Two BJTs are biased in active region and have identical parameters with beta greater than 1. The open circuit small signal voltage gain is approximately. The open circuit voltage gain is approximately. क्या होगा यहाँ पर? In an AC equivalent circuit shown, the two BJTs are biased in active region. Right, both are normally the BJT, when we want to make it what, amplifier, then it should be biased in what, active region. The open circuit small signal voltage gain is approximately, it is 1, -1, 0 or infinite. Because we are having the diodes, right? Watch this. We are having the different types of models. For example, it is a PNP transistor. It is what, NPN transistor. Right? Now, we are having models like what, RE model. RE model means this is the RE model. Alpha I. This is the base, this is the emitter, this is what, collector. You can use this model. Whether it is PNP or NPN, it doesn't matter, that will remain same. Alpha I, this is the IE. This is the direction of IE. Then second model is called pi model. Here you are using the pi, R pi. These all are approximated models. Here we are using the GMV pi. Early effect is negligible. No need to find a, no need to connect what, R0. And this is the voltage R pi. This is the V pi. This is the base terminal, emitter terminal, and this is the collector terminal. Right, that is the second one. This is the IC. small signal model. Third model, normally we are comfortable with what, this HI model. Now it is not in the syllabus of GATE, but yes, you can use, right? HFE into IB, hybrid parameter approximated model. This is the collector, this is the emitter, this is the base, and that is what emitter. And this is what IB. Normally we are using this model like this. HFE IB, and that is what collector, this is what emitter. And this is the HI, and that is what base. So this is again like a T model, but it is called T model. It is called what? T model, right? Now some student will use the model, right? This, remember this is the emitter. Let I am giving you, this is the Q1, it is the Q2, that this is the E2, this is the base B2, this is the C2, this is the C1, this is the E1, and that is what B1. So some student will make model, so they will connect it like this. There are different types of model. You can use any type of model. Now, here this is the emitter, this is the RE, this is connected to ground for first one. Second, this is the base. Here we are giving the input. Here this is the alpha IE, and this is the IE. Okay. Now, because they are connected in series, the current will remain same. Because these are connected in series, the current will remain same. Now, this is connected to what? Collector. Change the diagram. This is the alpha I. This is the RE. Right? In this case, this is the diagram. This is the base. This emitter is connected to what? Ground. This is the E2. Emitter is connected to ground. Emitter is connected to ground. Base is connected to collector. This is the C1 and C2. This base is connected here. Right? And from this collector, we are taking the output V0. Okay? And that will be the diagram. Right? So here simply watch this diagram. This is the VI. And when we are giving current, this is the alpha, this is the alpha. What will be the current here? 2 alpha I. Now this 2 alpha I is distributed in what? Alpha I here. Now at this point, we are having this current is 2 alpha I, this current is alpha I. So what will be the current from that? Alpha I. Right, alpha, we can remove this alpha because the beta is very large. So what will be the alpha? Nearly equal to 1. So this current is alpha IE. This will become, right, and in this way. Now my dear friends, what is the V0 by Vi? Very, very simple. Because the beta is very large, so alpha is equal to 1. Beta is very large, so alpha is nearly equal to 1. So Vi is equal to, what is this? IE into RE. IE into RE. This is the Vi. What is the V0? Write down the KVL from this point to this point. You will get minus IE into what? RE. RE cancel. This is the minus 1. Answer is what? Minus 1. Right? No. It will not change, Surjit. Because whether it is NPN or PNP, whether it is a NPN or PNP, the model will remain same. If suppose you are going to change the direction of this current, then simply you have to change the direction of this current also. Right? Yes, that is the value. So we can say this. What is the, I am not giving the, I am just simply solving the in terms of what? RE. What will be the current here? Because I am using this current, and that is the value. Right? I am simply using what? KCL here. In this point, KCL here. Because that current is I, that current is alpha I, this current is alpha I, and so on. Because I am giving the same direction. Suppose I am changing the direction of this, then I have to change the direction of this also. Because in case of PNP, IE is outside, collector current is In case of NPN, emitter current outside, collector current inside. In case of PNP, emitter current inside, collector current outside. Then I have to change direction of both this. No need to change. Same model is applicable, whether it is PNP or NPN. Everyone, please remember this formula. Now, no need to solve like this. No need to solve like this. You can connect the model, but you can get the value. Sometimes we are getting the same question from MOSFET. Tomorrow we are going to discuss op-amp and what MOSFET. 11 AM sharp. ओके आज थोड़ा टेक्निकल इशू हो गया था, चलेगा. एक और मेथड है, सिंपली देखो डायरेक्ट. व्हाट इज दिस? VBE. यार वी आर हैविंग द वैल्यू VBE 0.7 वोल्ट. ठीक, VBE 0.7 वोल्ट. NPN ट्रांजिस्टर इट इज कांस्टेंट. व्हाट इज दिस? VEB. बिकॉज द करंट आर सेम करंट इज फ्लोइंग लाइक दिस. And that's why this VBE and VEB have the same value. In PNP it is VEB, in NPN it is a VBE. Now you can write the V0 by VI. Watch. Write down the KVL from this point to this point. You will get the V0 is equal to minus VEB. What is the input? When I am writing the KVL, it is the VBE. Minus 0.7 upon what? 0.7. This will become what? Minus 1. Directly you can find without using the small signal model. Without using the small signal model, you will be able to solve this type of questions. ये हो गया. That is on small signal model. This is very important. Remember, we have the 3 types of model. You can use any type of model, but connection, there should be a proper connection. C, beta E. When the beta is very large, alpha is equal to 1. When the beta is large, always use beta. Normally beta is very large, 1. Base current is 0. Right. You can also use this model. This is called H parameter model, HI. That is just like a T model. Emitter, collector and base. Proper connection. Always remember this is the base current. This is the HFE-IB. Same model is valid for PNP and NPN transistor. This is called pi model. This is the IB. Right. This is the pi model. And always remember, in pi model you have to calculate the GM, that is called IC by VT. And again you have to calculate the R pi also. What is the R pi here? Beta by GM. Sometimes they may ask question like this: what is the value of the R pi? What is the value of GM? So IC is the DC and VT is the volt equivalent of temperature. Calculate this, then calculate R pi. In case of RE model, you have to calculate the RE. What is the RE? RE is equal to VT by IE. VT by IE. So number of important formula based on what? This model. So RE is equal to VT by IE, R pi is equal to beta by GM, GM is equal to mod of IC by VT. Remember this. But when we are using the hybrid model, no formula. Directly they will provide you the value of HIE and HFE. HFE means beta. Means these 2 models are highly accurate because we have to calculate the value of RE and we have to calculate the GM and R pi. But in case of hybrid model, everything is given by what? Manufacturer. We are not able to find the exact value according to the temperature, according to the real condition of DC biasing. And that's why this model is not so accurate. Okay. Okay. Next one. Sometimes we are running very easy question like this from BJT. Electrical students, electronics student, what will be the answer? Sometimes we are getting the 4 kilo ohm, 1 kilo ohm, 2.2 kilo ohm, 300 ohm. What will be the value of IC and what will be the value of VCE? Right, what will be the value of VCE in this question? Assuming that the beta of the transistor is extremely large. Assuming that the beta of the transistor is extremely large. And VBE is equal to 0.7 volt. VBE is equal to 0.7 volt. IC and VCE in the circuit. What will be the value of the IC? That same current will pass through 2.2 kilo ohm. Then 300 ohm. And what is the value of VC? Beta, when the, always remember, when the beta is very, very large, what will be the base current? 0. Same IC will pass through this. Always remember, in transistor, all the resistors should be normally in kilo ohm. So 300 ohm means what? 0.3 kilo ohm. And current will be in milliampere. Current will be in milliampere normally. Resistor in kilo ohm in case of BJT, and voltage in volt. Voltage in volt. Voltage in volt. These are the units. Okay. Chinmay, first we apply the KVL in the open loop. Where is the open loop? Which case? You are talking about this diagram, right? In this case, first of all, you have to apply what? Potential division rule. Cut this. This is the 5 volt connected here. This is also connected. 5 volt is also here. 5 volt supply. Then potential divider means 1 kilo ohm, 4 kilo ohm. This is the 5 volt. You have to find the Thevenin's equivalent here. What is the VTH is equal to 1 divided by 1 plus 4 into 5. That is nothing but 1 volt. And RTH here, 1 parallel with the 4, that is the 4 by 5 kilo ohm. That is the RTH. Once you will get the VTH and RTH, then again you have to connect this diagram. So then this will become, this is the RTH. This is the VTH. Now connect the diagram. What is the RE? 0.3 kilo ohm. Here connect the value of the RC, 2.2 kilo ohm. This voltage is 5 volt. RTH, the base current is 0. So what is the need? Why we are calculating the RTH? Just wasting our time. No need to calculate the RTH when the beta is very, very large. Only calculate the VTH. Because in limited time we have to solve number of questions. So don't waste your time. Why we are calculating the RTH? Because there is no drop across the RTH. Then simply this voltage is 0.7 volt. This voltage IC plus IB, but IB is 0. And that's why it is IC. Directly write down the equation and you will find the value of the IC. So IC is equal to 1 minus 0.7 divided by RE 0.3, and this you will get the 1 milliampere. 1 milliampere is the answer for what? IC, collector current. 1 milliampere. Now what is the current here? Second one, what is the value of the VCE? What is the value of VCE? Simply write down the KVL from this point to this point and you will get the finally VCE. So what is the KVL from this point to this point? 5 is equal to 2.2 IC plus VCE plus 0.3 times of IC. This is again the current is what? IC, and this is the 0.3 kilo ohm. Then you can find the value of VCE. 5 minus 2.5 IC. IC is 1 milliampere, and that's why it will become 2.5 volt. Answer is C. 1 milliampere and VCE is what? 0.2 volt. Okay then. So this is all about what basic idea about the BJT and the diode. This is these two topics are very, very important for what coming exams like BARC and HAL. And if you want the detailed PDF of this class, then join my Telegram channel, that is Electronics by Sanjay Rathi. Okay, Electronics by Sanjay Rathi. And tomorrow we are going to discuss some important numericals on operational amplifier and what? MOSFET. MOSFET, DC analysis of the MOSFET, as well as what? AC analysis of the MOSFET, and some important numericals on current mirror circuit by using the MOSFET. Okay, then thank you for attending the session. Please like the session, subscribe the our channel and share the link of this session. Thank you and good day.